capsule. The results of a survey eliciting data on undergraduates' use of coping strategies and level of emotional intelligence indicate that emotional intelligence is a predictor of self-efficacy, and self-efficacy is a predictor of academic success for computing students and plausibly, by extension, for non-traditional students in STEM. Summary: a continuing trend of declining undergraduate enrollments in computer science and related majors and subsequent persistence to graduation has motivated computing educators to identify explanatory factors and traits, and subsequently develop strategies to foster academic success. Bellinger et al. 2007 report the results of a study to investigate the influence of two psychosocial traits, emotional intelligence and use of coping strategies, on academic success as defined by self-reported in-major GPA. Self-efficacy serves as a covariate because of its previously demonstrated predictive ability of academic success. The research hypotheses are based on the primary assumptions that the degree to which students use problem-based coping strategies as opposed to emotion-based strategies and their level of emotional intelligence are predictors of academic success. A secondary research topic is whether there is a difference between computing and non-computing major undergraduates with respect to the traits. Survey participation was solicited from upper-level undergraduates from over 20 universities on the assumption that juniors and seniors are more likely to have declared a major than freshmen and sophomores, and thus are more likely to have an in-major GPA. Data on coping strategies were gathered using Andrew Guppy's cybernetic coping scale, and data on emotional intelligence were gathered using Nicholas Schute's emotional intelligence scale. 626 students responded to the web-based survey. The analysis is based on the responses of 613, 223 non-computing majors, and 390 computing majors, upper-level undergraduates with declared majors. With respect to demographic data, the computing majors were significantly older than the non-computing majors, mean age of 23.1 versus 20, and spent more hours per week volunteering, mean of 2.9 versus 1.6, working at the paying job, mean of 13.6 versus 5.6, using the computer for non-academic purposes, mean of 3.72 versus 2.38, and studying, mean of 3.3 versus 2.8.
Okay.
None of the research hypotheses was supported. However, it was found that, for computing majors, emotional intelligence is a significant predictor of self-efficacy, which in turn is a significant predictor of self-reported in-major GPA. Computing majors differ from non-computing majors with respect to mean scores for emotional intelligence, 3.96 versus 3.7, and accommodation coping strategy, 3.26 versus 3.06. The authors give several reasons for these outcomes, basing their observations in the literature. One factor to consider is the significant demographic differences between the two samples. Choice of major may matter less than age and experience. Mixed results exist regarding the relationship between age and emotional intelligence, and between age and use of coping strategies. Implications for engineering education. Noting that the nature of these relationships is an open question, it may be that a generalization of the results to non-traditional students is plausible. Non-traditional students often face many of the challenges that other students from underrepresented populations in career and technology studies, Lufkin et al. 2007. By extension, non-traditional students in engineering may be vulnerable to similar marginalization. Instructors may find that strategies used to integrate and motivate students from underrepresented populations in STEM are appropriate for non-traditional students. Also, instructors may want to take advantage of the non-traditional students' experience and presumed indicators of maturity, such as emotional intelligence, in developing lesson plans and lectures, assigning students to teams, and conducting discussions. Awareness and consideration should not just flow from instructor to student. However, instructors may need to manage a different set of student expectations when working with non-traditional students, and students should be aware of their roles in the instructor-student dynamic.